after we understand the virtual machine concept, so let's talk about again to see when we run a source file from the C++ code and how they will compile and run on the computer. Remember this one, you may see that in your previous class in COMSC 110 or 165. Remember we show you if you write a source file in the CPP file, you maybe just have an int main cout hello world. So then this file we will save in the CPP file. That's what we call the source code. Most of you write the CPP file in a text editor, then you run on the command line. Or so far, actually, a lot of class we just using the IDE. You maybe use the Visual Studio or Xcode. So that's why here is your C++ source file. Then you one click, you see the output on the console. That's because IDE combine everything for you. So when you click the Run button on your IDE, actually they process many steps. The first one, we see the preprocessor. Right, because you see you have your CPP file, but your CPP file may need to include some library file. If you have any library file, the preprocessor will go to find the default library. Then remember we told you they actually just copy and paste the whole library CPP file or H header file into your source file. So that's why you see after you have your preprocessor, you modify the source file. The source code actually being updated, but as a programmer, you won't see that. So that's the IDE, the first thing they will do. They will have preprocessor to include all the library into the source file and modify the source file. So then that's what we call the compile. So the compile actually is converts your human-friendly source file into the object code. So this object code, actually, we will show you the object code in the future class. Maybe in chapter 3, I will show you. The object code actually is not be runnable, but that's the compiler compile from the source code, then they generate the object code. The object code usually ends with the .obj file. So it's just not runnable, but sometimes we can view the object code. So in this object code, actually, you will see the source file being translated into the assembly language. Assembly language, sometimes also the object code, they show you the machine code. So the object code actually is not really execute and run. They just, after the compile, they translate the source code. So then we add all the linker. So all the linkage to make the executable code being executed. So this executable code usually is .exe file. So here I also add the source code file. You see the extension will be CPP. Even we modify, they still using the CPP file. So then the object code will be .obj file. Then executable file, they will be exe file. Usually they will be with the same name, but different file extension. So actually before, when you write C++ code or Java code, you one click from the IDE, they run the source file, but actually they pass through so many different steps. So the most important thing actually in the virtual machine happens from here. Your virtual machine, you need to translate your CPP file into the assembly language. So then assembly language translates into the machine code. So this class will only focus on the assembly language, but you need to understand the relationship between the assembly language with high-level language and the machine code. So that's convert this one into our virtual machine structure. So actually here, when you write a C++ code or Java code, that's your high-level language. So in the specific machine language, virtual machine level, they look like this. Actually, like we say, they all have different language. So the high-level language translate into the assembly language. Assembly language translate into the instruction set architecture. So mostly we say that's machine language. because they have different instruction name and tells you how to do that. But instruction language doesn't mean they will really run, because remember, your hardware is built by the circuit. So that's why the instruction set architecture also need to translate into the digit logic. So those things happen when you have a source file, then you compile and run, then the digit logic is really make your hardware to run and display your output in the screen. So then you can see that's the 4 level for different specific machine level. So then one by one you can see, like we say, your level 4, they are application-oriented programming language. You have Java experience, you have C++. So of course, Python, Pascal, Visual Basic, all the programming language you can think about from the human-friendly high-level language, they are all, as we say, the level 4 high-level language. So those programs being compiled into the assembly language. So then compile, actually we can say they translate and compile into the assembly language. So let's go to the level 3. So when we come to the level 3, you can see what is level 3. That's what you will learn from this class. Assembly language basically is instruction, mnemonic instruction. So like earlier we show you, you have add, you have sub, you have imode, you have code. They have one-to-one corresponding to the machine language. After you have assembly language, so then they will translate into the machine language. So after the program are translated into the machine language, the first level actually is instructional set architecture level. That's machine language including the instruction, but those instruction is not really like assembly language. It is the mnemonics instruction. Human can understand. Instruction set in the machine language actually just number only, but usually they display in the hexadecimal. But in order to make computer to understand, right, then we go to see the machine language. So machine language is here, you see the level 2. We call they are instruction set architecture, or we say that's the conventional machine language. All the instruction is 1 byte in the hex number. For the specific processor family, they have their matching table to refer to which instruction what they will do. They still cannot really run by the computer yet, but they are pure machine language. So in order really make the computer hardware understand, they need to execute into the level 1. So then we will translate the machine language into what we call the digital logic. So the digital logic is pure 1 and 0. So those digital logic, they will work in the CPU, construct from the digital logic gate. Then you will see they have different system data bus. They can pass the address, they can pass the data. Of course, we need to access the memory. So then they are implemented using the bipolar transit. So you see why? Because bipolar, you see computer is making 0 and 1. That means positive and negatives. So that's how we'll make the digital logic can really run on the hardware. So let's see here. Before in our COMSC 110, COMSC 165, even our Java class 255, or your computer science 210 data structure class, we all focus on here. But after you implement your source file, you can be wrong and see the result on the screen. That's because they go over all the following level. In this class, we will see the example for the machine language. Digital logic, basically we are not touching with that, but you will see the Boolean algebra to see the truth table. So kind of they have the logic information and concept there. But this class in COMSC260, we focus on the assembly language. We are not translating from the high-level language. Actually, you need to write the assembly language code. So then we need to learn the syntax. So the assembly language, like earlier we said, mostly they are instructional mnemonics. So then you will see different instruction. Then you can work on the bits. So then we will show you the example when assembly language, you implement that, you need to compile and run. Then they will have the machine language example. So that's the instruction for our computer science 260 class for the assembly language. So again, remember, anytime you should post a video if you don't understand, refer to the textbook or write down your question. I will answer your question in our Zoom meeting. So that's our first week lecture. So next week, we will really show you in detail for the assembly language example.